answer your queries live, and those queries can be related to your project work that you are doing, or related to some concepts regarding the steel or RCC projects, or maybe related to your site or construction related queries. So this is the fourth episode, and we will straight away start with our uh, session. That is, we will start with answering your doubts. So let us jump right into it, and we will start from where we had left in the last session. And so how can you put your queries? You can just put it in the Google form, or you may also type your queries in the live chat. First, we will start by taking the queries that have been put in the Google form. Okay. If you just want to have the link for Google form, I'll just put it in the live comment in the YouTube comment section. So maybe you can take it from there. Yeah, I've just put it. So I'll begin by answering the queries which have been submitted in the Google form. Let us start with that. First question is, how do we wait a minute. Yeah. So first query is by engineer Yogesh Devre. So this is where we start from. Till the last question we had covered it in the session number 3. So we start from here. He is saying Mr. Yogesh Devre is joining from Pune. He is a working professional, and he is asking how to apply E-tabs 5 times vertical acceleration to the cantilever beams. So as per the IS 1893 requirement, you need to apply the 5 times earthquake load to cantilevers, and there are certain conditions given to it. So how to apply? Let us have a quick discussion about it. So first of all, we will see how to apply the vertical coefficient. So what is the vertical coefficient given? What is the vertical coefficient given as per IS 1893? Is someone aware? Anyone? So the vertical coefficient value is given as 2/3 of Z by 2 into I by R into 2.5. So it basically takes a fixed value of SA by G, that is 2.5, and you do Z by 2 into I by R. You take that 2.5 and then you do the 2/3 of it. Okay, so that is what your code says. I'll just copy that, maybe screenshot I'll take and just paste it over here. Where is it? Yeah, I hope you can see this. Just a minute. Give me a minute, please. Yeah. So 2/3 of this we have to apply. 2/3 of this particular value is the AV vertical coefficient. 2/3 Z by 2 into I by R for buildings governed by 1893 Part 1. So for any regular building, this is what you can do. So this is the basic definition of AV. Now, if you want to apply this in ETABS, the first thing that you should do is that you should be assigning this value in your. So you need to create a response spectrum function in your ETABS model. Let's see how to do it. So you can just go to define, create a new function, okay, and just give any name. So maybe I give this name as vertical, maybe acceleration, okay, and wait a minute. I can have this as user defined also. So let me give it user, and let me give this as vertical acceleration. Okay, so now what you will do is, because the vertical acceleration has a constant function value as we just saw, which is just 2 by 3 into I by 2 by 3 into z by 2 into I by r into a fixed value of SA by g, that is 2.5. So suppose you wanted to calculate this for, let's say, a zone 4 structure. Let us do that. So suppose you wanted to calculate this function for a zone 4, and maybe my response reduction factor is, I don't know, 5 or maybe 4, and importance factor is 1.2. So what will be this AV value? So it will be zone factor this into 1.2 upon 4 into 2.5, and I'll do 2/3 of it. What is the answer? Mr. Manish is saying screen is not visible. No, no. This OneNote screen is visible. Just do this calculation. What is the answer you're getting? So I think you will get a 0.06 as your answer. So this becomes your AV value. And remember, this becomes now independent of time period. So no, no. So this becomes independent of time period. Now this value we shall put it into our ETABS response spectrum function. So I'll just take you over there, and we shall put it now. So let's quickly do that, and I shall put it. Okay, how do I put it? I'll just again show you. You go to response spectrum function, define, and you go to response spectrum function over here, and then you define this. Maybe you can define it as user defined function. Let's name it as AV. So now this is a constant value. So just give it a constant value 0.06. Okay, and so at t equal to 0, time period equal to 0, the AV function will give you a value of 0.06. At any other time period, let's say time period equal to 10 seconds, also the AV function will have the same value, 0.06. Is this window visible or not? I don't know. I think the second window is not visible. The second ETABS window that I just opened, I guess that is not visible. Wait a minute. What should I do? Now what is visible? Now I don't know what is visible. That infinity type of thing is happening, right? Mm, yeah, not visible. There is some problem in sharing that I'm facing. Just a minute. Let me just see how to take care of this. So if I'm doing entire screen, does it solve the purpose? There is an infinity mirror that is happening, isn't it? I don't know how to. Now when I tab to this, I'm not sure what is visible because I cannot tab it back and see what's happening. So I'm assuming it is visible right now. Yes, no? Okay, I'm assuming it is visible. So you will do it this way. You define it AV. Okay. Then what do you do? Then you will have to. Okay. So then comes the second part. We do the function definition AV. Then you go to the code once again. So when you go to the code once again, it will have one more point to tell you, and that will be that just like we do the Bayesian scaling for earthquake response spectrum. Now similarly, how to do the Bayesian scaling for, so for horizontal earthquake we all know how to do the Bayesian scaling. For vertical earthquake how to do the Bezier scaling, it says in the vertical direction, the multiplying factor shall be taken as maximum of these two. So basically, it means whatever is the Bezier scaling factor for x direction response spectrum and for y direction response spectrum, you just take the higher value of it, and that becomes the Bezier scaling response spectrum value for uh, response spectrum earthquake in z direction. Is it clear? So now that means once again, if I go back to ETABS, how it will happen? So how it shall happen? So it will happen this way, that you go to define and you go to load cases. You define a new load case. So maybe you give a response spectrum Z, whatever, and this shall be response spectrum. This time you go give the acceleration value of u3, and function will be the function that we had defined, AV, vertical acceleration function. This scale factor, as I was explaining, this will be the higher value of scale factor that you have derived from uh, response spectrum X or response spectrum Y after the Bezier scaling has been completed. So suppose the Bezier scaling factor in response spectrum X direction, you got it some, maybe some 18,000. Of course, multiplying 9806 by the Bezier scaling factor. So whatever you got, that 18,000 from earthquake from response spectrum in Y, you got some 20,000 Bezier scale factor. So then for this, you shall put the value as 20,000. Is it clear? So the higher of the Bezier scaling factor, you shall put it over here. So this is how you can define the response spectrum in Z. And then if you want to assign this, and maybe for large horizontal projections, if you want to use this for design, then the thing becomes simple now. You have given a straightaway clause in IS 1893 that for horizontal projections, you will take 5 times the vertical earthquake. So 5 times the vertical earthquake means, because we have defined the response spectrum in Z function right now, what you will do. So now you can make a load combination, and how that load combination can look like. So that load combination may look like something like this. So you can probably make a 5 times response spectrum in Z and whatever other load combination factors you have. So now you can create a load combination. For example, you can create a load combination like this: zero point 0.9 dead plus 1.5 into 5 times response spectrum in Z. Response spectrum function, we already created it in the ETABS just now, as I showed you. Okay. Si- Similarly, you can have a 1.5 dead load plus 1.5 into 5 times this. So your code tells you to multiply the AV by 5 times, but because we may not like to multiply the AV by 5 times, I am just multiplying the load combination factor by 5 times. It will give you the same outputs. Okay. So this can be a way ahead, or this can be a method that can be adopted for uh, considering or for designing your large horizontal projections for vertical earthquakes. Okay, this can be one of the ways, by understanding the codal provisions and then using the options in ETABS. Is that clear? Also, one thing more, when you want to do the when you want to consider the vertical earthquake, then you should do one more thing, and that is that you go to the seismic mass definition, mass source definition in ETABS. And one more thing that you should do is that you should include the in the mass source. For example, you include the vertical mass option over here also. Okay, so include the vertical mass option over here also and press OK. So that is what you should do when you want to run for or use the vertical earthquake for your large horizontal projections. Clear? Okay. So this was his first question by Mr. Yogesh from Pune. And now I move on to the next question asked. So let me just quickly go. This screen sharing is slight problem in this software that we are using for YouTube Live. It is not a very seamless experience. So yeah, that is there. So let's move on to next question. Now we have a few questions from Mr. Manish Parmar. He is joining from Dehradun and he is a postgraduate student. So I'll just copy all his questions, take it to OneNote, and maybe there we will try to answer his queries. So let me just do it. I hope my screen is properly visible, voice is properly audible, everything is okay. Okay. So his set of questions: how to design battens manually for moment and shear given in the formula. So battens, there have been regular questions asked about battens. So batten is all of you know battens. I need not explain. So let's say this is my column face. I'm trying to draw a built-up column in elevation, and these are my batten plates. Now I want to design these batten plates. How to design them? So your code has a straightaway procedure for it. What does it say? I'll just bring that clause from IS 800 over here. So I will go to IS 800 and go to the 7.7 point something clause. 7.7.2.2. So it says no 7.7.2.1 I think. What does it say? It says this. So it says battens shall be of plates, angles, this, whatever, and you need to so as to resist a shear of the shear in the batten is Vt into C upon N into S, where this is the C distance, this distance is C, and this distance approximately is S. Okay. Now, what is this Vt? So, please understand what is this Vt. Vt is this external shear. Okay. External horizontal force that is being acted upon the batten. Now, if you have just assume a case, for example, that you have some actual lateral wind load acting on this column. Okay. There is some wind load acting on this column, maybe some 10 kilonewton per meter. Assume that your battens are some 300 apart. So roughly speaking, how much shear will you say is transferred to this batten, or how much of I should say how much of the lateral load will be transferred to this batten? Tell me. So the approximate load that will be transferred to this batten will be, let's say, 10 kilonewton per meter into 0.3 meters, because 0.3 I am saying is the spacing. Or let's take it 0.6. 0.6. So how much is it? Whatever 6 kilonewtons, and assuming that there are two battens, one on this face, the other on the other face, so this gives you whatever was your answer. So how much is this? 3 kilonewtons. So what this means is that the force getting transferred is 3 kilonewtons transfer shear. Do you understand? Okay. So this becomes my transfer shear. Now this I will put it over here as the value, and then I shall calculate VB, that is the shear to be resisted in the batten by the cross section. Then I will also calculate the moment, that is the moment to be resisted by the batten due to this shear force. No, wait a minute. Wait a minute. I think I don't have to do this divided by 2. Uh, just a minute. I think we did not. Okay, we need not do it by 2. Okay, because in the formula there is a n value. So I need not do it by 2. So I'll put 6 kilonewton over here. I'll not do it by 2. This n value gets put it as 2. So I get my BB. From here I also get my M. So these are the moments and shears to be resisted by the batten cross section. Now this has to be compared or cross checked against the capacity. So the shear capacity of any batten cross section, you can find it by our basic uh, formulae that are given. So for example, this was a, I don't know, 6 mm batten plate, and this depth was 200 mm. Just taking rough example. So this becomes AV into Fy upon root 3 into gamma V, whatever, gamma M L, whatever is the safety factor I have to take. So AV will be my cross sectional shear area 6 mm into 200 mm. So from here I get my shear capacity of this cross section of the batten. Similarly, I can calculate the moment carrying capacity. So I can write it as what? I'll take it as a semi compact section. Generally, in designing these plate elements or elements of connections, usually we will take it as a semi compact. So ZE into Fy upon gamma m naught. ZE will be what? B into or D into T square upon, sorry, T into T square by 6, where D becomes my depth, 200, thickness is 6 mm. So from here you will calculate the moment carrying capacity of this section, and then you shall compare it with the moment on the batten and shear on the batten. So naturally the shear on the batten, if it is less than the capacity, that means our batten cross section is safe. Similarly, if the moment in the batten is less than the moment capacity of the batten, that means cross section is safe. Okay, this is how you have to do it. This transverse shear, as I just explained, you should also check it with respect to the 2.5% of your axial force in the column. So that means that if this transverse shear value is, let's say, numerically very small, as we were getting in this case, then you should also check the shear forces arising from a transverse force that we assume it equal to 2.5% of the axial force on the whole member. So if my axial force in this entire column is P, you also take a 2.5% value of this P. So transverse shear 2.5% of this P. Okay. If there is any external transverse shear, then you calculate that also. Whichever is the higher value, you take that for your batten force and moment calculation. Is it clear now? Okay. So Mr. Manish is asking, this 10 kilonewton per meter load on batten is 2.5%. No, no. This 10 kilonewton per meter we had assumed just as if there was a wind load acting on this column. So see, transverse shear either can be due to any external load acting on the structure, or this transverse shears will be due to 2.5% of column axial load. So whichever is the higher value, transverse shear generated due to external load or transverse shear due to 2.5% of axial load in the column, whichever is the higher value, you take that as your VT value and then calculate the batten forces and moments and then compare it with the capacity. Clear? Okay, so I hope this is done. His next question was, for low-rise RCC bare frame building with infill walls, which table of IS 875 Part 3 do we need to use for the coefficient calculation? So in the wind table, there are a lot of tables and you will have to work your way around to identify which table suits your requirement. So generally for these types of multi-story frame structures, if you want to look for a table, the closest table, in my opinion, will be will be this table that is given in uh, this figure 4. You see, clad buildings of uniform cross section. So this figure 4 table, actually this table is the same. This figure is the same figure that we even use for tall structures to calculate the CF and then multiply it by the gust factor. So even for low rise buildings, the same table you can use. Is it clear? Okay. So there are two figures. You can already see what is H, what is A, what is B. So there are two figures. Figure A is for H upon B greater than 1. That means when the height to plan ratio is more than 1, you will use the figure A. When your height to plan ratio, the dimension perpendicular to wind, that ratio is less than 1, you will use the figure B. So mostly in your low rise structures, you will have to go to this figure B to calculate the CF. Understood? Once you know the CF, then you can multiply it by the respective tributary area on which that wind force is acting, and then you can transfer it to your elements like beams, columns, etc. Okay. I hope the answer is clear. All right. Then his next question was continuing with Mr. Manish and his questions. His next question was, I don't know if you're able to read it. I hope so. Okay, so his next question is, as per the table 20 of IS 875 part 3, why the pressure coefficients for roof and base of tank are given with a negative sign. So see, negative sign means away from the face under consideration. That is quite clear, and that is what you have also mentioned. So if you go to figure 20, uh, we are soon planning to start a course where we will exclusively focus just on the wind load application and wind load calculation. So what we hope to do in that course will be that we will try and go through each and every table given in IS 875 part 3, try to understand them. We'll also have a look at ASC 7 and see how it is different from the Indian code. AC 7, the wind portion, that is. We will also discuss the gust factor approach given in the Indian code, and then we will also discuss understanding and interpretation of wind tunnel testing results. So very soon we are going to do that. We will soon start this course, maybe in the year 2025. So I think that type of a thing will be helpful because many of these things, how to apply wind loads for different situations, is still slightly problematic to us. Anyway, so these coefficients are given for different h by d's ratios. The coefficients are given on roof. The coefficient is given on the bottom also. Understood? So it's quite simple how you do it. It's quite simple how you do it. So what I will do is maybe I'll just take a complete picture. Okay. And what should I do? What do I do? Yeah. So now, sorry. Okay. So in this D portion, we are with this D, let's say. So very simple to see roof coefficient. If it is minus, that means it shall go away from the roof. Okay. If for bottom also it is minus, that means it will go away from the bottom also. So basically, what might be happening that your wind currents are blowing like this in elevation, of course. So they are creating a suction on both the roof and the bottom. So basically, this is how your wind currents are blowing, creating suctions on both the faces. Is it clear? So that's why there is a negative sign in for roof as well as for bottom. Okay. So that was three questions asked by Mr. Manish Parmar. He was joining. He's there joining from Dehradun. Now we move on to next set of questions. Let us see what is the question. So Mr. Tosh Agrawal is asking how to provide eave strut. Wait a minute. Okay. So Mr. Tosh Agrawal is asking. He's joining from Raipur. He is a working professional. How to provide eave strut in PEB structure? Do we have to provide it in rafter or column or rafter column junction? Please clarify. So see, many questions related to PEB. I think you need to first understand how the system works. For PEB also we have done an entire course, and during the course we have discussed that this kind of a handbook is very convenient and easy for us to understand more about the PEB systems. So if you wish to learn more about PEB systems, when I say PEB, I just mean to say the pre-engineered building shed-like systems. So if you want to learn more about PEB, what I will suggest is that this is a very good resource. It's a handbook developed by Zamil Steel. Most of you may be aware they are one of the pioneers in this type of building systems. They are a very old company, and now it's a big conglomerate having different companies across the world as part of this conglomerate. So they have come up with this very good handbook way long back in, I think, 1990s. So this type of a book, it's very easy, it's very effective way of understanding the PEB system, and most of the PEB systems still follow these kinds of, I would say, structural details still. So his question, what Mr. Tosh was asking, was how the eave strut gets connected to the rafter column junction. Does it get connected to the column or the rafter? Where does it get connected? So if you see this detail, it's quite helpful. I don't know if you're able to see it. Uh, I don't know. Or what I can do is maybe I can just bring it to the OneNote. So first of all, I'll just recommend every one of you that you can always download this handbook. It is freely available on the internet. It will help you to understand a lot of things about different systems, connections, connectivity for PEB shed-like structures. So here, if you see what's happening, one of the possible options that they have given, I'm not saying it is the only option, but sort of they have standardized what they are doing, that this is my rafter. On the rafter, they have provided a clip like this. Okay, understand it to be a cleat that gets welded on one side. There are bolt holes, and now you will place your eave strut over here. So this is my purlin, and this is my eave strut. Okay, so eave strut has been bolted, and now it will, then it gets connected to the eave clip, that what they have named, or you can call it as a cleat. At every rafter location, this eave strut gets connected. So if you see, they have made this eave strut free from the rafter column junction, and they have tried to fix it on this cleat. Okay, so this can be one of the alternates possible. I'm not saying it is the only one of the possible solutions, but this is one of it. And because they wanted to standardize everything, it's a simple option, because then whatever is happening over here in the rafter column junction, if there is a stiffener or whatever there is, you don't have to worry about it. You can just put a cleat over here and attach your eave strut to it. This can be one of the option, or then you attach it in the panel zone of the rafter column, although that is not very appropriate way of putting it, because in the rafter column junctions there are shear deformations and other issues. So you might not want to put it in the rafter column junction per se. So I think this is a good position to put your eave strut. Okay. So for these types of questions, what I will suggest is that you must go through this steel handbook that I just mentioned. It will help you to understand a lot of these standardized details. And when it comes to these details, as I told you, There cannot be one solution or one answer, one specific answer. Suppose you are doing a PEB system, pre-engineered building system, you may come up with a different solution. They have come up with this kind of an arrangement. Okay. All right. Then Mr. Tosh is asking, please clarify at what location bracing in PEB need to be connected to column and column rafter joint so that eccentricity in horizontal and vertical bracing connection can be ignored. So again, ideally I would want to make the, as far as possible, I would like to make my column rafters location free from any other connection, because then there is always this problem of stiffening of the rafter column junction that we need to do. So as far as possible, we shall make it free of that. So usually we will try and connect our elevation bracings below the column rafter junction. I'm just looking for some bracing section if I may get. This is an excellent resource, okay? You must go through it. Everything has been explained. You see, Mr. Tosh, here they have shown, where is it? Here they have shown the eave strut. I think here you will understand it even better. Are you able to see this? Eave strut, how they have connected it. Yeah. So here they have put it on the top. In the earlier image, they had put it on the side of the side of the column. Whatever you choose, it's your system. You can come up with any solution. Understood? So bracing locations, if you see over here they are showing the bracing. Okay, this is a cable bracing. I just need, okay, yeah. So here if you see, they are showing the bracing connected to the column rafter intersection, if you see over here, through a cleat. Okay, in many of the systems they will not put anything in the column rafter junction. They will put it slightly below so as to keep the column rafter section free from any other secondary connections. So you can come up with these connectivity solutions. So there is no one right answer for this. You have to come up with these systems, or you follow what are the systems that people have sort of standardized. Okay. But if you ask me, try not to put anything in the rafter column section, because there is always that problem of yielding also. So we may not like to have anything, any other attachment to that at that location. Okay. All right. Then what is next question? So Mr. Tosh was asking, Mr. Saif, who is joining from Delhi. Okay, so he is joining from Delhi. I think he was joining from Guwahati. Acha, Mohammad Saif Ahmed is joining from Guwahati. Uh, Saif is joining from Delhi. He is a working professional. His question is, while doing anchor bolts, he has some question related to anchor bolts. Let me just put it over here, and then we'll try and answer it. So, what do I do? Yeah. So, Mr. Saif from Delhi is asking, while doing design of anchor bolts, if we take negative support reactions from stat for design of anchor bolts, but in mezzanine structures I got positive Fy only, so which force should I consider for design of anchor bolts? Please clear this doubt. Oh, I also got a doubt after reading your query. I don't know. For anchor bolts, negative support reactions. Okay, so negative support reactions, if you're getting it in stat, probably it will show you, I don't know what it will show you, uplift in the column. Negative support reactions will show uplift in the column for you in the stat if you go as per the stat sign convention. So No, negative will show you or no? I'm also confused. What direction will show you? I will also have to check it in stat. So right now I will not go into science. Concept is simple. If any in your stat, in any of your column, if there is a uplift, and I'm not going into negative positive, I'll have to cross check once again. So if there is an uplift, that means the column is trying to leave contact from the base plate. It needs to be pulled down. So he'll pull it down by use of anchor bolts. That is fine. Now he's saying in mezzanine I got only positive Fy. I don't know. I think he's saying in mezzanine structures maybe he's only getting downward loads. There's no uplift that he's getting. This is what I'm inferring. So he's saying what shall be considered for plate design. So if it is C, assuming a case where your column is under pure compression, under all of the load combinations considered, there is a pure compression in the column. So technically, if you say C, there is no need for anchor bolt because this column is already going to transfer its forces through this base plate into the concrete pedestal. So technically, there is no need for anchor bolt. Okay, but still we will put some holding down bolts, minimum minimum numbers of anchor bolts just to hold it down. And then how will you design the base plate? So base plate will be designed for the bearing pressure that is getting generated from the column load transfer to RCC pedestal through base plate. So base plate will be designed for the bearing pressures, and if the column is all compression, there is no movement and there is no net uplift anywhere in the column, then technically speaking you do not require any bolts. You can just put a base plate, have a column on top of it, load will get transferred through bearing between the base plate and RCC pedestal. But still, of course, we will provide some minimum number of anchor bolts. Did I say column? Anchor. I hope you got the question. Okay, Mr. Manish, answer. You got the answer. Mr. Manish is from Dehradun. He is a postgraduate student. No, sorry, he is a postgraduate engineer, and he is asking. So he is basically asking about that 2.5% rule. When we say that a member shall be considered to be an effective member which can provide effective lateral support against the lateral torsional buckling, we usually say that you design that particular member for 2.5%. So for example, if there is a beam in plan, okay, and suppose you are providing these two green members as part of your lateral torsional LTB or members providing lateral restraint. I've also added point diagonals or diagonals because only adding these two beams may not be effective lateral support. You have to also add such kind of relative, sorry, bracing systems like this. So anyway, so when I can say that this is an effective lateral support, when it is able to take 2.5% of the compression in this member. So whatever compression force is in this member, if my green beam is able to take 2.5% of it in compression, then I will say it is an effective lateral support. So his doubt is how to check this in cold form purlins and guts. So suppose this green member was not a hollow, not a I section beam. Suppose it was a cold form, cold formed purlin or cold formed gut. So that means now I have to check this purlin or gut cross section. Suppose it's a Z section. So now how do I check this Z section for axial load, axial compression of this 2.5% of the axial load in main member. So that means now I have to check my section, cold form section for axial loads. So how do I do it? So well, I cannot use the IS 800 because if it's a cold form purlin or gut, chances are that it will be a thin thin section. So now I will have to either go to IS 801, but because this is a very old code, people these days may go for AISC S100, S100, AISC S100, released in 2016, I think. Or you may take guidelines from AISC 360 and AISC S100. So basically, these are the cold form design standards, or you may refer to any Euro code or whatever other country codes that you want to refer to. So the basic answer I want to give you over here is that in these cases, you will have to design your cold form section for axial loads, and those checks you will have to make. So you will have to go to some design standard to do that work. Okay. Okay. Moving ahead. Then we have next question is from Mr. Saif Ahmed. He is joining from Guwahati. He is a working professional. He is saying, please guide us. What is saying? So he's saying, please guide us. How do we provide anchorage to just a okay. So he's saying, please guide how can we provide anchorage to the foundation for controlling uplift? What should be the minimum length embedded into the ground? See, in one of the project discussion series that we used to have earlier, we had discussed this how to calculate the rock anchors, especially in footings where there are chances of uplift and you are getting a good strata where you can do anchoring. How you can come up with a rock anchoring system. Some basic calculation we had done it over there. So you go to the project discussion series on our YouTube channel, go to the episode 1. We have discussed over there a small little example of how you can do it. So I'm not repeating it over here. I'll just refer you to go to that. Suppose you're not able to have rocks and you are not able to anchor these. I mean, there is nothing that you can anchor in. So maybe then you can think of piles, if pile is a possibility. So pile, because they can take friction, they will give you the anchorage that you needed and that your soft soil may not be able to give you. So in such situations, you may go for anchoring using piles, friction piles. Uh, and if you already have a hard strata, if rock anchoring is possible, as I just told you, you can go to the project discussion series episode 1 that is there on our YouTube channel. You will get some sense of what I want to tell you. Okay. His second question is, can you please explain about sensitivity analysis, upper bound, lower bound? So this we have discussed in great detail in our ongoing course on tall buildings design. Sensitivity analysis is not difficult. You just have to make, if you have a tall building with a podium system, you just have to make two models, upper bound and lower bound, because you want to see, or rather because your podiums are also helping you in lateral force distribution. So you basically want to see the podiums at two levels of stiffness. When I say podium, I also mean to add any existing basement walls and other podium slabs. Any horizontal, any system which is taking the lateral load due to wind and earthquake acting on this tall building and transferring it to ground, I am adding all of them in this podium system. So anything below podium which is there to resist the lateral load and transfer it to ground. So basically, sensitivity analysis means you will take two extreme situations, one where your podium is offering very low stiffness and one where your podium is offering higher values of stiffness, and then you will check the effects, and accordingly use those effects for your member design. So remember that this sensitivity analysis is part of your collapse prevention, as your code says. So it is not to be checked for any service level check. We will only check it for the ultimate limit state level checks like member design. That means when you want to find out the member reinforcements. Okay. So sensitivity analysis, you will take a situation where podium is offering very little stiffness, that becomes your lower bound. One situation you will take where podium is offering some mild level or some intermediate stiffness, that you call it as the upper bound. And you already have a situation where your podium is going to offer its actual stiffness, so that becomes your normal backstay or your normal model. So in the normal model, your podium will offer whatever it is offering as per its normal levels of stiffness. Then you will have a upper bound and a lower bound. So in this way, you are checking the sensitivity of your tall building due to the different effects of podium stiffness. That's why we are calling it as the sensitivity analysis. Okay. For more details, there are some good YouTube videos that you can get online, and I will recommend you to watch it. Or you can also see the provisions given in IS 16700. You can go through them. It's not very difficult. It's a very easy thing. You will be able to do it. Just watch some resources online or offline, or search for some documents on the internet. Okay. So I'll move ahead and let us see what is the next question. Mr. Sheikh Ahmed Jawad, he is joining from Bangalore. He is an independent consultant. He is saying that whether we should take service model or strength model. Okay. So this is also an issue which needs some deliberation, whether we should take the strength model or service model. Actually, these things will arise if, for example, if you are doing your structure as per IS 16700, many of you may be knowing that there is a stiffness modifiers given in the IS 16700, and there are two different sets of stiffness modifiers given. One is for the limit state of serviceability, the other is for limit state of collapse. So this means that you have two ETABs. Basically, if you are doing a structure using ETABs or whatever software, you will have two different models prepared. One becomes your strength model, other becomes your service model. So strength model will have the modifiers as per the ultimate limit state. This will have your modifiers as per the service limit state. Further, for example, if you are applying wind loads, your 16700 quite says it quite clearly that you will apply a wind load corresponding to 50-year return period in the strength model. When you are checking any service related issues, you will apply a wind load corresponding to a 20 years return period. Similarly, over here, your response spectrum will be scaled response spectrum. Over here, your response spectrum is unscaled. Are you with me? What I'm saying? Okay. So these are the basic differences that you will have if you are basically using or referring to IS 16700 and doing, let's say you are doing a tall building. So then this case will appear that you are making two different models and working on it simultaneously, and you will call it a strength model and a service model. So now the question what Mr. Sheikh Ahmed Jawad is asking, which of these two models should I take for footing design? So I also have my mixed opinion on this. I mean, I think service model should be taken for footing design, Okay, but here, so what is happening in the service model? We have assigned the service level modifiers. The wind load has been assigned for a return period of 20 years. Response spectrum load case is unscaled. So for footing design, my opinion was to take the service model for footing design, check the bearing pressure, check the bearing pressure for the foundation sizing. Once your foundation sizing is done, then for thickness calculation of your substructural system, or let's say pile cap calculation or whatever, then you use the ultimate load combinations. Okay, while doing this, my opinion is that because your wind is now for a return period of 20 years, and because your response spectrum is unscaled, now you do not allow any increase in safe bearing capacity of soil for load combinations involving wind or earthquake. Do you understand? What happens is usually we are allowed to increase the safe bearing capacity of soil by 25% or 50% depending on what type of soil we have for load combinations which involve wind or earthquake. Do you know this or not? And what is the justification we give? So the justification we give is that because there's a lot of safety factor in the soil, and because wind loads and seismic loads we are taking at higher levels, therefore we do this. So maybe in this case, because you are taking lower levels of wind loads, because your response spectrum is unscaled, maybe if you take the service model for footing design, you don't allow any bearing capacity increase while checking for load combinations involving wind and earthquake. That is my personal opinion. But when I have also discussed this issue with practicing structural engineers, they take the strength model for footing design. So strength model means the wind speed is for a return period of 50 years. The response spectrum is scaled response spectrum, uh, and the modifiers are as per ultimate limit state. So they take this model for footing design. Now, in this model, as per my opinion, then you may allow. So basically, bearing pressure will be checked in this model itself, and for thickness calculation, you will use the ultimate load combinations for thickness calculations. That is, I mean, that remains as it is. Over here, in my opinion, then what you should do is because you are using the 50 years return period and scaled base shear, here you may allow SBC increase if required, that is for load combinations that are involving wind and earthquake. Is it clear? That is my opinion. So if you are using the strength model and taking it for footing design, because you are using 50 years return period and scaled base shear, I guess you may allow the, or you may permit increase of your bearing pressure beyond the SBC value for load combinations involving wind and EQ. Okay, so this is what I just wanted to say. Now, his main question wanted to ask was that in such cases, how do we maintain these two models? So basically, if, for example, you were going to take, let's say, the service model to footing design for footing design, and your beam reinforcement due to beam reinforcement requirement or column reinforcement requirement, you changed a few sizes in your strength model. So your service model will have some different sizes, strength model will have some different sizes. So that is not allowed. Obviously, we'll have to maintain two models as same means the sizes of my members in both the two models have to be maintained same, because we all know that the stiffness affects the analysis results. So you have to ensure that the sizes are maintained the same in both the models. And as I explained, you can take any of the model for raft design or foundation design to safe, but these are the things you should follow depending on which model you are taking. Okay. So most of the people whom I talked to, they said they are taking the strength model for footing design, but I don't see why I cannot take the service model also for footing design. And while doing it, I can ensure that I do not allow any bearing pressure increase. Okay, so these were my thoughts. Uh, I'm not saying it is the only option possible. So you can inform what type of option you practice or what is the scheme you follow, that you may inform if someone wants to tell us. Okay. All right. Going ahead, Mr. Vinay RB is from Davangiri. He's saying, what is this question? He's asking design of single flight staircase, position of support for this type of stairs, geometry parameters, this, the deflection criteria. See, you must understand one thing, that the staircase design or any type of staircase design should, I mean, the logic remains the same. It does not change with the change in staircase arrangement or staircase configuration. Okay, so you may have, there are different types of staircase options possible. So whatever is your staircase, you need to understand the logic and then move accordingly. What is the meaning of single flight staircase? Single flight would mean that there's no turning that you're getting. Maybe this is my steps, this is my mid landing, and again steps continue like this. So there is no change in the direction. So his question is how to do it for this. So again, you need to plan your supports. So maybe your supports can come in the form of column, and then you can have a beam attached over here, whatever is it, whatever it is. Or you may take a single column like this maybe, and have a stringer beam like this maybe, and then take these steps cantilevering out from the stringer beam. Or you may have brackets created like this, take it from this element, take these brackets at different levels, and on these brackets this staircase will support. So whatever your system, you can try and work it out. Main thing is, in most of these cases, it might turn out to be a longitudinally supported staircase. If you have taken the entire system cantilevering out, maybe let's say you had a RCC wall over here, in such a case, you can take the entire system cantilevering out from the RCC wall itself. In this type of a situation, your staircase will be a transversely supported staircase spanning like this. So whatever is your system, accordingly you will have to design. So staircase questions are difficult to answer, because if you understand the logic, how to design a staircase, the system may be different, the logic of doing it remains the same, the process of doing it remains the same. Okay, that does not change. Okay. Then we have next question from who is asking. Mr. Devlin is from Oman. He is saying that he has a. Okay, I'll just take it to OneNote, and he has shared some images also on WhatsApp. So let me just try to bring that image also over here. Just a moment. I'll just take it. So his question is, that he has a wide beam. Yeah, he has a wide beam like this, and he has modeled it like this. So is it a correct way of doing it? I don't know what you are able to see over here. Yeah. So his question is that he has a single wide beam passing. If you see, okay, I think he is asking about this beam. So this beam is 120 centimeter wide. I guess that means 1200 wide, and it is getting connected into the column only in this portion. It's not getting connected in the column in the other portion. That is his question, I guess. So he's saying no moment or shear is getting transferred to main beam. Eh? Okay, I think what he is trying to ask is how to model these situations. Maybe that is what his question is. So in such situations, what you can do is, in such situations, what you can do, you can make what is called as a rigid link. So suppose I wanted to make this column. Now what is happening that this is my central node as such. So in this center line, no beam is getting connected. So actually, if you see, my beam is over here. Okay. So my beam center line is over here. So if I were to strictly follow line modeling, my center line of the beam lies over here. And you can see it is not passing through the column center. What you can do in such cases, one of the option is to create a maybe a rigid link over here. So how to create rigid link? You can go to etabs and you can go to link properties. In there, you go to, you can define a rigid link and fix or lock all the degrees of freedom over there. So you will get a rigid link, and that rigid link you can connect it to your beam column center and take it like this. So this becomes your rigid link. To this rigid link your beam is connected, and this is my blue beam, 1200 by 450 wide beam, blue because this color was blue. So in this manner you can do your modeling work, at least for this situation. While executing it practically, what you need to remember is, now I'm drawing a elevation. This is my column elevation, let's say, and I had a wide beam which was going to be connected like this. So a very small portion of this beam was on the column, large portion of the beam remained outside. What do I do in such cases? So basically I take a bracket from my column like this. Understood? So that bracket is actually equal to the beam depth. Bracket means reinforcement bracket. So in reinforcement itself, I have taken this type of bracket, and on this bracket, I can have my beam reinforcement resting. So in colloquial language, this bracket in place where we live is called as a todi. Okay, so it's a hidden bracket that we have taken out from the face of column just to just to support a beam which was not concentric with the center line of the column. Okay, so we call this type of a reinforcement bracket that we do as a todi. So maybe you can do it that way. And for analysis in ETABS, as I told you, you may use the option of rigid link. Okay. So I hope the answer is clear. Okay. Moving ahead, let's see what other questions are. So Mr. Tosh is from Raipur is asking, please explain in PV rafter to column connection. So I think you do this, Mr. Tosh. As I told you, I will suggest you to go through that handbook, the wheel steel handbook. Many of your things, I guess, will be covered over there. And then, if any doubt remains, you can put it in the Google form for the next episode. Okay? Yeah. So you do that. Okay. So because many of your questions are related to the system, maybe it will be better if you go through that handbook. So going on to next set of questions, Mr. Alek Katuwal, who is joining from Nepal, he is a working professional over there. So he has asked a few questions. Let us try and answer his doubts. His first question is, how can we apply moving escalator loads in ETABS? See, even if your escalator is a moving load, understand that it moves at a very slow pace. So we really don't have to worry about its motion as such. All right. Also, because it's quite light, it's not a very heavy system. So if you ask me, we are not very worried about the escalator dynamic load as such. What we have is usually the escalator supplier will give some sort of a data sheet for loads, and then we can directly use those loads that have been given in the data sheet, and we can put it in our ETABS model or whichever analysis software you are using. You can put it over there. I was just trying to search a sample data sheet, how it looks like. Just give me a second. I'll just search for one of the projects we had uh, got such kind of a data sheet from the supplier. Give me a minute. I'll just search if I get it. Just a minute. I'm searching something. Okay. I don't know. I'm not getting escalator. Escalator. No, I'm not getting. Okay, I'm not getting it over here right now. So maybe I'll have it ready for the next time. But anyway, it's a simple data sheet, just point loads given and where to apply it is given to us. So you really don't need to apply any moving load. Simple answer. Just apply the loads as dynamic loads. The escalator company, they will take the necessary dynamic impact factors and give you the loads that you will apply it as simple static point loads. All right. His next question is, I have found the change in behavior of mode shapes while meshing structural walls. That's quite interesting. What is the correct procedure for meshing structural walls? Usually like and mesh it in elevation. I like to mesh it at around 1 meter, at every 1 meter. Okay. Along the floor length height, unless it's a case of basement walls where you are applying any lateral loads due to earth pressure or liquid, you may not mesh it along the height. That is my view. In the plan dimension, in the plan along the plan length, you may mesh it at around every 1 meter. It's a good mesh size to have. Okay. If you want to find out the optimum mesh sizing, then you can go for one or two or three trials where you will change the mesh size, observe the change in output, and accordingly decide what is the optimum mesh size to keep. Okay. Okay. The next question is, for small buildings, in some places we have to add structural walls to control torsion, or building having lift walls. My question is whether we have to design it as a dual system. No, I don't think so. I don't think so. Just adding one wall does not mean it becomes a dual system. I may not so. I may not say so. For underground tanks in building, his next question is: shall we consider the water load as live load or dead load? How does it matter? See, whenever you have any confusion whether to take any load as dead load or live load, always think to put it under a load case where it will give you highest level of impact. That means, for example, in seismic weight, if you are going to do dead load plus zero point 0.5 live load, so basically the impact of live load is going to decrease. So then in such a case, put the water tank water load in the dead load so that the impact remains highest. Understood? Other than this, in all the load combination, or for example, you are going to take dead load plus zero point 0.8 live plus zero point 0.8 EQ for particular checks. So your live load is getting reduced. In such a case, put the water tank liquid load in the dead load so that you get the worst of the possible results. So whenever you have any doubt whether to put anything as it is varying with time as dead load or live load, always think of it this way, that whatever will create a greater impact, you try to put that load under that particular load case. Okay. Okay. So this was Mr. Adek. He was joining us from Nepal. Mr. Sheikh Ahmed Jawad from Bengaluru is asking, kindly explain the various edge release options in ETAPS. Okay. So edge release options are very easy. I'll just show you in ETAPS what is happening. And for that, I think again there is a problem that I will have to, I don't know what I have to do. I have to share my entire screen, I think. Okay. Yeah. So it's very easy to assign the shell releases, edge releases. You choose whichever shell you want to release, and things are quite simple. So I'll just show you what's happening. Yeah. So suppose I wanted to assign. So I just suppose, for example, this was my sunk. This entire area was to be sunk. So I wanted to assign some edge release. How do you do it? Assign shell edge releases. You choose the edge. If it is a specific edge, you go on toggling between these edge numbers. You will see the changing node numbers, and then you can just see the node numbers over here. Accordingly, you can decide which edge is getting released. Okay. Other than that, the important thing to be understood is this edge release data. So I think for better understanding, I will just take it to the OneNote, and there I'll just paste it so that we can understand it in a better way over there. I hope the screen is visible. So what are these edge release data options? If you see, I'm drawing a plan view of my shell, and these are my edges. So in plane shear force. In plane shear force means any force acting in this direction. If you want to release that force, then you will release the in plane shear force. In plane direct force normal to edge. So any force which was, let's say, acting in this direction, normal to the edge, under question, then you will release or you will put a tick mark over here. The third is out of plane shear force along the edge. So if you were to say that there is a shear force acting perpendicular to the screen of this laptop or whatever screen, if there was a shear force acting perpendicular to the plane of the screen and acting in a direction or acting on this entire edge, but the direction remains perpendicular to the plane of the screen, then I'll call it as the out of plane shear force. Understood? Then I have a bending moment about the edge. So that is just simple right hand thumb rule about this edge. So whatever is the twisting bending moment about this edge, if you want to release, that becomes this option. Twisting moment along the edge, if there's any in-plane torsion twisting happening along this edge, then you put a tick mark over here. So this means whichever option is applicable for you, you put a tick over there, and on whichever edge you want to put that, you assign to those edges. So suppose assuming that this wanted to assign this as a sunk, and I wanted to make this entire slab act as a sunk slab. So which options I'll use in such a case? Who can tell me? Out of these available edge release data, which option shall I use? So in my opinion, you will choose all the edges and you will try to release the bending moment about the edges and the out of plane shear along these edges. Is that clear? Okay. So this was about the edge release and its understanding. Mr. Saif is saying 1 and 2. How will it be 1 and 2? You just go back and see what I explained. So the releases will be the out of plane shear force and bending moment about this edge. Clear? See, in plane shear, in plane direct force is anyway not going to affect any of your analysis results. So if you give it or if you don't give it, it won't matter anyway. Okay, moving ahead to questions. Let's quickly finish. Mr. Vikas is joining from Delhi. Can you share your views on how to read a soil report and interpret important aspects? Oh, I think in our course that we have conducted on foundation design, we had discussed this issue for close to 4 sessions, which is almost 6-7 hours, about what items should be included in a good geotechnical testing report or how to read a soil report. So I think I'll not answer it over here because it's a very long explanation. So I mean, as I just told you in one of our courses, we had spent close to 6 to 3 sessions, I think. So better not to take it over here. Uh, I don't know how to give a short answer for this. How to give a short answer? I don't know. I mean, short answer for me is not possible. Short answer. Yes, anyone can just tell me. What are the important key points that you need to see in a geotech report? So I think you should see some of the key aspects that your geotech report should contain is the number of samples and location, whether they have taken it properly at the places you had mentioned. You should see whether they have collected the undisturbed samples and disturbed samples properly. You should check what type of testing that they have conducted on disturbed sample, what are the type of tests that they have conducted on undisturbed sample. You should go through the soil. Okay, yeah, you should also check whether they have collected the soil water sample, and whether they have taken the soil sample for chemical analysis of soil. That you should check. You should see whether they have tested the site for water table presence. Okay, you should then also check. So once these things are done, then you should check what are the outputs they are giving you. So you should see properly that the bore log data is properly given to you or not. You should see whether the bearing capacity calculations. Let's say there was a case where you are going to provide footings. So bearing capacity calculations have been given to you with respect to the settlement criteria and shear criteria both or not. Some people don't check for the settlement criteria. They'll just give you a shear criteria, that's it. So it should not happen. You should check for that. You should also see whether or not the if you had a high seismic zone, and if you are making a tall or a big structure, you check whether the soil has been checked for its liquefaction potential or not. Okay, then you should also check whether the soil has been tested for backfill use or not. If there are deep excavations coming, you should check that whether the soil has been tested for slope stability or not. So there are these checks that you should do. Checks, by checks I mean you should see whether these things are part of your report or not. If it's a good report, it should be included. These points should be included in your report. Okay. So as I told you, it's a long explanation. It cannot be curtailed in such a short time. We have done a detailed discussion in our foundation design course. So, but these are some of the key highlighting points. Okay. Okay. Moving ahead. So, Mr. Rohan Joshi is from Jalgaon. He is a postgraduate student. He's saying, I am a PG student. I'm in confusion whether to start my career from MNC or a consultancy which is in structural health monitoring and retrofitting work. His long term goal is to start his own company. My view will always be that you start from any company which will where you will get greater responsibility to work. Okay, and plus your company should have some good seniors and mentors who can guide you. So if you go to a very big company, what will happen that you will have good mentors to guide you, but then you will be working only on a very small piece of that project, or a very very specific area of that project. Okay, so that is the risk you have if you are working in a big company. If you are working in a very small company, it may happen that there are no seniors who can guide you, and you may be entrusted to take the entire to do the entire project on your own, but you might not have the capability to do it on your own. So actually it's a mixed. I mean, you gain some, you lose some. If you work in an MNC company, there are issues. If you work in a small company, there are issues. So maybe some mid-sized company where there are some good seniors to guide you also, and where you are given greater responsibility to work for. Maybe you can do that. Okay. Okay. Mr. Hitesh is joining from Vadodara. He is a working professional. He is saying, please share difference between AISC Design Guide 4 and 16. Oh, I am not aware. I am aware of the AISC Design Guide 4, which is, I think, the extended end plate connection beam column. But which is the AISC Guide 16, I am not aware. Maybe if you could put it in the mail, in the next episode, we could take that. Okay. Okay. So, next question is Mr. Wasif from Pakistan. He is a working professional. He is saying necessary deflection checks for designing a building, their limits. So, Mr. Wasif, as I understand, you might be using the American codes over there. So, each and every country code will have its respective checks for deflection limits. So those deflections usually are vertical deflection limits, and there will be a so one of the deflections will be the total vertical deflection that you need to check. Okay, vertical deflection that you need to check. That is one of the limits. Then there will usually be a drift limit also. Drift limit means the relative deflection between two story levels. So there are some limits on that also. There is a limit on the total max deflection also. Then there will be some limits for individual members in. Oh, sorry, these are not vertical deflection limits. Wait a minute. These are horizontal deflection limits. Okay. Okay. Similarly, there will be some vertical deflection limits. These are usually for elements like beams or slabs, etc. These are more to do for gravity loads. So they are typically the limits are L upon some ratio or some value, permissible limit. So you have to check your member against it. So in such a way, there will be some horizontal limits, deflection limits, some vertical deflection limits, and you have to ensure that your structure has been checked and found okay against all such applicable deflection limits. Okay. For limits, you should go to your respective code that you are using and accordingly decide. Clear? Very good. So I think these were the doubts that we had in the Google form. Yeah. Now let us see if you have got any doubts over here. Mr. Aksar is asking, can you please advise? What is this question? Please, can you advise about crack width consideration for non-water retaining structures, which is normal underground sump pit having pump equipment inside the pit? So then you can go to IS 456 and go to section 5 where your limit state design starts. They have quite clearly given that for structures which are not in contact with water or which are not in contact with any aggressive environment, the crack width limit is I think 0.3 mm. If I remember it correctly, I'll just show you. So in such a case, that is the crack width limit you will need to follow. Okay. I'll just show you that portion of the code. It's quite clear over there. There's no scope for any confusion. So the starting of section 5. Yeah. So if you read this, the surface width of crack should not in general exceed 0.3 mm in members where cracking is not harmful and does not have any serious adverse effects. Otherwise, if members where cracking in tensile zone is harmful because they are exposed to effect of weather or continuously exposed to water, then 0.2 mm is the upper limit. For particularly aggressive environment, 0.1 is the limit. So in your case, maybe you can go ahead with a 0.3 mm limit for crack width. Mr. Magaj is asking tension column design and detailing. What is tension column design? No, ask specific questions. Don't ask concepts over here. Ask specific questions if you have on that. Okay. Mr. Magaj is then asking how to resist uplift in case of loose soil. So see, if you have a case of uplift and there is a loose soil also, maybe it will get tricky to uh, resist uplift. So in such a case, you will have to go to a strata which is not loose. You will have to use some underpinning strategy. Maybe that could be done through piling, or maybe some anchoring if it is possible by taking it to lower strata, or you may think of ground improvement, soil stabilization, and then using some anchoring over there if you have got loose soil till large depths. But I guess in your case, after certain strata, you will get a decent enough strata where you can do the piling work. So I think in such cases, maybe you could do that. But if you bring some specific examples, it will be easy to answer. TVZZ in one of the project, center of mass and center of rigidity were exactly coinciding, but building was undergoing torsion. In plan, large opening was there in central part. Yeah, that could happen. Even I could show you a building maybe of a irregular shape where center of mass and center of rigidity are coinciding, but still there will be torsion. Yes. So Mr. TBZZ is continuing. When shear walls were present near the opening, there was torsion, and when the shear walls were placed away from the core, torsion was not coming. Can you please explain this behavior? You yourself have explained the behavior. You yourself have explained the reason why that was happening. That when we took the shear walls away from the center, why the torsion stopped, you yourself have given the answer. Now just try to search more about this behavior. I think you will get the answer very easily. Okay. Yes, in your question or in your observation itself there is the answer. Mr. Saif, question what he had asked, I had some doubts on the question what he is asking, but I answered it to the degree of my understanding, and I think that was what he was trying to ask. Mr. Suraj is asking any plans of pipe rack course. Maybe we'll bring it in future, near future. Mr. Saif Chaudhary is asking any plans to start course on international codes and projects. Yes, in near future. Okay. Okay. So I think that is it then for today. We stop over here and we meet you next time now. Okay, there is one question asked by Mr. Narayan Moduli. He is from Odisha and he has asked couple of questions. So let us try to answer those questions. So what I'll do is I'll just share my screen. Okay, so Mr. Narayan Muduli, he's from Odisha, is asking how to assign earthquake loads in hydraulic structures. I don't have any clue. I have never applied earthquake loads in any of the hydraulic structures till now. But as I understand, there is a complete part 5, if I am not wrong. Yeah, part 5, I guess. IS 1893 part 5, which deals with dams and other hydraulic structures. Maybe you could go over there I have no clue. I have never applied. Can you easily explain the sign convention for movements in plates and shells? Is you can. I'll refer. I will suggest you to go through some books over here because that will be easy for you to understand. Okay, it will be a long explanation. In our RCC course, we or in any of our courses, we usually try and discuss the sign conventions. But over here, it will be a long explanation. So you can go to any good online resource. You will get a good understanding of sign conventions over there. Okay. All right. Anything else? Okay then. So I think these were the questions that were asked for today, and there are no more questions on the YouTube comment section also. So I guess that is it for today then. So now we'll see you next week. And in the meantime, if you have any questions, try not to ask concept related questions over here because concept related questions take long time in answering. Uh, Sometimes maybe multiple hours also. So those types of questions are slightly difficult to answer in a limited period of time. So we may not be able to answer them. Okay. Try to ask some specific question. Anuk is asking how to calculate lateral strength for tall buildings. Very good. So if you see IS 16700, it has added a provision where it says to calculate the lateral strength, and it says that the lateral strength of your below floor shall not be less than the upper floor, something of that sort. Okay. But then it does not explain how to calculate the lateral strength. I mean, there is no explanation given. What does the code mean by strength? Whether we have to add the stiffnesses, or whether we add the moment capacities, or whether we add the axial capacities, what exactly we do, it's not given. Just give me a hold on. Yeah. So lateral strength, there is no conceptual explanation given whether that lateral strength is the summation of stiff. I mean, do we need to add stiffnesses? But then how do I add stiffnesses if strength is being asked? So what do I do actually when they say that lateral strength has to be done, calculated? I also don't know right now. There is no further explanation given in the code. Maybe to my understanding, maybe we have to add up the moment carrying capacities of beams, columns, add them up at a particular floor level. I'm not sure. So, to answer your question, I don't know right now how to calculate the lateral strength. Okay, but your point is well taken. I get it why you are asking because it is there in the code now, in one of the clauses that the lateral strength of such and such story shall not be less than the story above, something of that sort. Yeah. So right now I don't know. Neither the code tells us how to do it. Anything else? Okay then. So we stop and we will now see you next week. You can put in your questions in the Google form and we will like to take them up next week now. That's all. Thank you. We'll see you again. Bye bye. Have a good weekend.